minus 20 equals 0. Now, we've done this in terms of quadratics. It's an equation. We solve it. You have to have everything on one side to be able to solve it. We can't do the quadratic formula because it's not quadratic, but we can make it like a quadratic. So that's where we're going to use our synthetic division skills. So thinking about what it is, we know it is third degree, and we know it has 3 solutions. Now again, those solutions can be real, rationally irrational. They can follow me bend this backwards, and then I could do it better. They can be imaginary. We're staying away from the imaginary. All of them today are going to be real rational numbers. Nothing crazy. They're going to be 2/3 and 5 and -3 and 7 and all that kind of stuff. So here's what we want to do. We want to be able to factor it, and then we want to be able to tell what the solutions are. Now this is going to come across the same, what it's going to end up looking like, after I let you get it copied. Well, I actually have one right here I just used. It's like this one. You've got, I used this for Algebra 2 Honors a while ago. If I have 0 equals x squared plus 5x plus 6, whether I do it by the calculator or whether I do it with a quadratic formula, I'll get x plus 2 and x plus 3. When I set those equal to 0, I get x equals -2, x plus 2 equals 0, x equals -2, x plus 3 equals 0, x equals -3. So this is it factored, and this is its 2 solutions. So that's the difference in factoring and solving. Now, you can go about it different ways of finding these things, but you got to have something to get it to where you can use the quadratic formula. So I'm going to make it easier by going below here, and I'm going to give you one of the solutions. I'm going to tell you that x equals, let me give you x equals 2. Now, this is going to go back to factoring on the calculator. Okay, when your calculator gave you 7 as the solution, do you remember how we wrote the factor, x minus 7? When the calculator gave you -1 as an answer, then x plus 1 was your factor. So if x equals 2, then my factor is x minus 2. Now remember the other day we talked about factoring as being things that will go into it evenly. I think we used that term. I know Allie and I did. And then sometimes I don't know if saying it comes out even is totally correct, but anyway, I've said it all my life, and I guess we'd probably be better off saying it comes out with a remainder of 0. So if I'm going to get a remainder of 0, then when I do long division or synthetic division, that's exactly what I need to happen. I know this is a factor, so I need to do long division. If I can divide, I need to do division. If I can divide this into this, then the remainder will be 0. I know it has to be 0 because we've already said it's a factor. We're writing the factors across here. So remember synthetic division? We take the opposite of this, which we're going to take a 2. And by the way, it's the opposite of this one, or it's the same as this one. And I think you just need to be consistent. It's either the opposite of the factor or it's the same as the answer. You can use either one you want. I wouldn't go back and forth. I would just say, especially if you just wanted the answers and you didn't want the factors, then you would just use the same number. But you kind of got to think about that. Then we use our coefficients. If it's third degree, we have to have 4 terms. We have them, 3, 2, 1, none. So let's take our 2 and our -13 and our 28 and our -20. And if you haven't done lesson 37, now, the check dates are going to be out a few days, and then the due date is out a few days from that. Now, if you wait till the night before the check date, you're going to have things that you're going to be doing things in here that you haven't done on classwork yet. So you just kind of just got to decide. And I don't think we know what kind of work you're fixing to run into. I don't know if you've already been loaded down today or if it's looking good. We just have to play it. I mean, mine's pretty much running like it was, but are you going to get a lot of other work? I don't know. I'm just curious how it's going. Now, if you remember, we bring the first number down. It's that 2. two twos, don't let it bother you. Bring this one down. But here's the whole thing. When I section this off, it's going to have to be 0 because I know it's a factor. So I'm going to go ahead and put my 0 there, because if I don't get 0, I've done something wrong. I've copied it wrong. I've done something wrong. Got to wear the mask. I know, it's hard, Colby. Got to wear it. And then I do 2 times 2 is 4, and I add, and I get -9. And then I do 2 times -9 is -18, and I add, and I get 10. 28 minus 18 is 10, and 2 times 10 is 20, and I add, and I get 0. Now, do you remember that if this is cube, then you're going to come down a degree, and I want you to write it not here. Don't put it up here with these. Go below it and write 2x squared minus 9x plus 10. Now, what you've done, and it's kind of weird, and I'm going to put equal 0. It's not that. It's the rest of this. We're saying this has to equal 0. And this is called a depressed, just like depressed, a depressed equation. I know it's kind of weird. I think the word better, compressed, it's like you took it from a cubic down to a quadratic. Now, why do we love a quadratic? Because a quadratic formula will factor it for us and give us the 2 answers. Now, you're probably not going to write everything twice. This is a lot of work that you may not put everything, but I'm going to show you, you will have to show your synthetic division for me. You will have to show this, and you may just want to write it once up here. I want to show you where it's coming from. So get your calculator, get your quadratic formula, and let's factor it. Now, I've already got the quadratic formula up, so I'm going to just hit enter. And my A is 2. See, it will only do quadratics or quadratic form. And we haven't had that. I don't know if we will, but it will not do cubics. I can just tell you that. 2, -9, because you can only put in 3 numbers. See, and these are always got 4 up here. And then what, 10? Okay, so underneath here are 2. We're going to actually write them. We didn't write them in our classwork the other day. The 2 answers are 5/2 and +2. Now that 2 is different than this 2, so I'll show you that too. There's a couple ways that you can write it. Now, do you remember with the calculator, if the answer was -6/7, you did the opposite, and the top became the second number, the constant, and the bottom number became the coefficient of the variable. So in this case, the 2 is going to go right here, and that's going to be 2x. And the 5 is going to go right here, and this is positive, so we're going to put a negative there. And if x equals 2, then again, some of you did it this way. The 1 is going to be the coefficient of the x, which is x, or 1x. It's going to be minus, and then 2 is going to be the numerator. Now, your decision to whether you want to write it here or write it up here, because, see, probably I would have had this on my paper, I would have typed in my quadratic formula, and I think that's the way we'll probably do it here in just a second. And instead of writing all of this under here, I would just go up here and write it. 2x minus 5 and x minus 2. And the other answers are comma, there's another 2, and there's a 5/2. Now, that's a lot to digest, but let me talk to you about it. When you learn to do the factor tree of 12, whatever grade that was in, I don't know when you start doing factor trees. It's after 3rd grade because that's when you do your multiplication tables. And you learn the factor tree of 12 is 2 times 2 times 3. Well, all 3 of those numbers, and in that case it has 2 2s. You can't just put 2 times 3 because 2 times 3 is not 12. It's got 2 2s in it. Now, we did learn on up in grades that you could write it 2 squared times 3. That's the same thing as 2 times 2 times 3. I'll show you that here. You can, all of those go into it with a remainder of 0. So I know that x minus 2 goes into this evenly. I did it here. If I were to take this one and divide it, and it's a little crazy, but you have to use the 5/2. But even if you put the 5/2 here and did the arithmetic, it looks like it would be horrible. It still comes out really easy like this. It still comes out integers with a remainder of 0. 2 is a divisor, 2 is a factor, 2 is a factor, and 5, let me back that up. 2 is a solution, 2 is a solution, and 5/2. If you put 2 in here, it will give you 0. If you put 2 in here, we've done that already, and then 5/2, and then 5/2 will make it 0. If you put 5/2 and type it in across there. The reason when they repeat like that, they're called, these graphs look like, if we decide to do these, it's going to be like this. What's 5/2? 2 1/2. Okay, I'm going to spread out my 1, 2, 3. So it's a 0 here and a 0 here. And cubic equations do like an S on its side. And so this one actually, was it negative or positive to start with? Okay, so it's going to come down. And the reason that 2 is repeating is because it's just going to touch it there. And then somewhere it would turn, oh, I didn't do a very good job of it. And then it would turn around and come back down. Should have done that under the camera. But that's the idea if we were to graph it, that it's touching, so it would be 2, 2, and 2 1/2. And that's where that comes from, because those are what those answers are.
How do you get the first 2?
It's given to you. I will give you this. Yes, let's write given here. Thank you for asking that. They will give you that. Now, if you didn't have it, Claire, what you would have to do is graph it to find one, and then because you would be able to see this one, because if you graphed it, it would look like this. And it would touch it too, and then you could do the division, and then you would get this. You would get the same thing, but you'd have to graph it and get one of the, and preferably an integer, because we don't necessarily know that that's 2 1/2. You know, it could be 2 and, 3/4, or it could be 2.8 or something. You know, you wouldn't know that one. And it's very time consuming to graph it. We don't want to have to be able to do